Why does algebra make you a better dancer? Because you can use the algorithm. Get it, rhythm, because like dancing and like music, and then algorithm, math is like the steps that you can do to solve a problem. It's great. Good problem. Good joke. All right, now let's talk about using algebra tiles to help us solve these problems and to represent these types of problems. So there's a link here that you guys can use to help you visualize and help you see algebra tiles that's going to help you guys out. So here's what the website looks like. And I'm just kind of going to talk you guys through what we're doing when we have these algebra tiles. Solving equations. There we go. So in this, you guys are going to see them using these long pieces to represent the different x's and these small squares to represent the constants or the numbers by themselves without the variable. So here we have an equation, x plus 3. X is that long bar, 3 are those small squares. And to show this how we do inverse operations to make zero pairs, you do the opposite operation. So you use the opposite pieces. So let's watch this one more time. I see I have those 3 yellows, but I want to get that x by itself. So if I do those 3 reds, that's like minusing 3, subtracting 3. The positives and the negatives eliminate each other so that I see that that one x bar is equal to 5 of those individual pieces, which is a bunch of ones. So let's watch it one more time. I see those 3 x's on the left, or those 3 ones on the left. I make 0 pairs with doing the opposite, making negatives, making those 0 pairs. Here I have 3 x's minus 1. To get rid of that minus 1, that negative 1, I have to add 1 to both sides. And then I see I also have to add 1 to the other side. We have to treat each side of the equation the same. Again, we're just making 0 pairs to get rid of things. Making 0 pairs to get rid of things to see what x is equal to. That bottom one, we're not quite there yet. That's when we have variables on both sides, but we'll get to that after map testing. Let's go back and look at this top one again because we kind of missed this last part. Because there's 3 x's, I need to put those yellow blocks into 3 different groups. And I see each one of those groups has 2 in it. So that means one of those x's is equal to 2 yellows or 2 ones, which makes 2. Let's watch that top one more time. Again, I add a yellow to both sides to make a 0 pair to get rid of that red. And then I rearrange my yellows into groups, 3 groups, and there's 2 pieces in each group. So again, what's going on in these problems? What are we seeing? What is this magic? We're making 0 pairs. Those are numbers that cancel each other out or eliminate each other. That's the word we've been using. Eliminate each other. We're doing inverse or opposite operations, just adding and subtracting to get rid of them. Again, we're trying to isolate the variable, trying to get it all by itself. And then we regroup those x's. We regroup those x's and those leftover ones to figure out what our variable equals. So let's do an example problem like this together. I see I have 2 x's and 3 ones on the right, and then 1 negative on the left. I know that I need to isolate my variables. I need to get those x's by themselves. So I need to make 0 pairs with these 3 separate ones to make each other go away, to eliminate each other. So if I add, or if I put on 3 negative ones on this side, that means I've got to do that same thing over here too. Make these negative ones on both sides. I have to keep my equation balanced. And in doing that, and making these 0 pairs, they eliminate each other. They are gone. They are gone. So now I'm left with 2 x's and 4 negative 1's. I want to know how much 1x equals. I want to know how much 1x equals, but I have 2 of them. So that means I need to put these 4 into 2 groups. So there's 1 group, there's 2 group, and each group represents a different one of those x's. So I see that one of those x's is equal to 2 negatives, which is a -2. If those algebra tiles are a little confusing to you, I'm also okay with you just turning this into an equation. We started with -1 on this side, and over here we had 2x plus 3. You can also rewrite it as an equation to help you solve. Your river of love, you subtract 3 from both sides, you get that -4 is equal to 2x, divide both sides by 2, and you get that -2 is equal to x that way as well. Either way works. If you like the visual piece, use the algebra tiles. But if not, you can just turn the algebra tiles into the algorithm to solve. Sometimes they're going to picture your algebra tiles on a scale like this. And I see here that my scale is balanced, so that tells me that this is an equation. If it was unbalanced, that means it would be an inequality. But here on this side, I have 2 x's, and I'm going to assume that that's a positive one. Unless it has a key telling you what's positive and negative, it's safe to assume that it's positive. And on this side, I have 1, 2, 3, 4, 5. Those ones are x's, so they're 2x plus that 1 is equal to 5 because they're balanced. If I'm going to solve this using the algebra tiles, remember I want to do the inverse, the opposite of what I see. So if this is a positive 1, I need to make a -1 on both sides to keep it balanced. But on this side and on this side, when I add in that negative, they eliminate each other, they make a 0 pair. Same thing over here. So now I have 2x on this side and 4 over here. And again, because there's 2 x's, I need to turn this into 2 pairs. So I see that each x then has 2 in it. So x is equal to 2. Go ahead and try this one on your own. This one shows the algebraically with the tiles. 2x minus 3, those are negative because it tells you it's -3, is equal to a +3. Pause the video, try solving this one either with the algorithm or with the algebra tiles on your own. All right, so to make 0 pairs, I need to add 3 positives to this side so I can get the variables alone. And if I add 3 here, I have to add 3 here too. These make 0 pairs. They eliminate each other. So all I'm left with here is 2, and over here I have 6. Again, because I have 2 x's, I want to know what just 1 x equals. So I need to put these into 2 groups. My groups have to be equal. And I see here that x is equal to 3 because there's 3 blocks in each one of my groups. If you've got questions on algebra tiles, let us know. We can set you up with some more problems. Otherwise, we're going to get into now word problems. Word problems. I have a strategy that I've been teaching my kids that we went over when we did one of our number sense routines in the morning was doing a word problem like this. Again, if you have your own strategy that works for you, use that strategy. Otherwise, I'm going to go over one to help you. So we want to pick out keywords and we want to draw a picture if that helps. This problem says Bella had, past tense, she used to have 7 Starbucks collectible cups. She bought 3 sets and now has a total of 22 cups. So how many cups were in each set? Pick out keywords to help you, draw a picture, whatever is going to be good for you. If you want to think about this with the algebra tiles, you can think about how Bella had 7 cups. So I could draw 7 little dots to represent those cups. And then she bought 3 sets. I don't know how much is in each of those sets. I just know that there's 3 of them. So I'm going to use my variables to represent, I don't know how much is in each of those sets. But she now has 22 cups. It's going to take me just a second. There's 20 and 2. So if I want to figure out how many cups are in each set, what I can do is I can make 0 pairs. So here I have 7. That means I need to get rid of 7 on each side. So I can also do that by going 1, 2, 3, 4, 5, 6, 7 gone there. 1, 2, 3, 4, 5, 6, 7 gone there. And then to figure out how many is in each set, I need to break this up. 3 by 5 is 15. If I break this up into 3 groups, I see that each one of these X's represents 3 or 5. So that means that there were 5 cups in each set. So that's the algebraic way if you like it that, or the algebra tile way if you like algebra tiles. But if not, I like to pull out little bits of information at a time. What helps me is to pull out information and then put it into my problem. Put it in that form y equals mx plus b. So first I need to pull out my total number. How many does Bella have all together? My total number here is 22. My constant, that's the one-time number. So out of my other numbers, 7 and 3, which one only happened one time? Yeah, the 7 cups. That's what she started with. Your constant is usually like what you're starting with, your original cost, like whatever was at the beginning. And then she bought 3 sets. So she bought it once, she bought it again, she bought it a third time. That number kept happening over and over again. That's my coefficient. That's my number with my variable. So that piece is going to be 3x in my equation. Then we need to think, are we adding or subtracting here? In this problem, we're adding because she bought more things. So that means she is adding to her collection. So now I remember y equals mx plus b. I plug in the equation or the information from my word problem. My y, my total number of cups is 22. My slope with my variable, my coefficient with my variable is 3x. The number of sets that she bought with, we don't know how many cups in each set, plus the 7 that she originally had, that she started with. Coming up with the equation, that's the hardest part. Then I need to go through and do my inverse operations to solve. So I subtract 7 from both sides. 22 minus 7 is 15. Then I divide both sides by 3. I see that 5 is equal to x. My question says, how many cups were in each set? If I say 5 equals x, I'm going to sound crazy. I would want to turn that into some words that somebody else can understand. I would say that there were 5 cups in each set. I want to answer the question, not give an answer like a robot, not just give a number, an equation like a robot. Go ahead and try this one on your own. If you like using the algebra tiles to model it, use algebra tiles. If you like using this method of pulling out information, use that method. Pause the video though, try it on your own, and then check back with me. In this problem, my total, Juan has 54 cards left. My constant, the number I started with, or the number that only happened one time, is 10. He sold 10 cards. That means he got rid of them. So that lets me know that I'm going to be subtracting here. Juan lost cards. He sold them. He got rid of them. So I need to subtract. My number with my X, the number that happened over and over and over again, would be those 8 packs that he had. 8 packs, but I don't know how many cards were in each pack, so that's why they're multiplied together. Then you should have put them into the equation in the form 54 equals 8x minus 10. Again, it's minus 10 because he sold some cards. Then if I go through and solve, do my inverse operations, I get 64 is equal to 8x, divide both sides by 8, and I get 8 is equal to x. But I'm not a robot. If somebody says how many cards were in each pack, I'm not going to say 8 equals x. I'm going to sound crazy. I would say there were 8 cards in each pack. And there you go. If you need extra help with word problems, please reach out. Send us a question, an email, a message on Schoology so that we can get you some extra practice problems and review it a little bit more with you. Good luck, guys.